later. There we go. Okay, there we go. Okay, so on number 1, we're trying to find the sum. I want to find f at x sub 2. Okay, so we've talked a little bit about functions and how to plug things in for functions. So I'm going to take this x sub 2 and I'm going to plug it into my function that I have right here. Okay, so let me start by just doing that and saying that that's m at x sub 2 plus b. Okay, so that formula may look a little bit familiar to you. If we put a y right there, you may have seen y equals mx plus b before as a line. Okay, that's our equation of a line. Okay, and so now I'm going to find this thing at a second term, and again, we call that x sub 2. Okay, so I know that x sub 2 is equal to this c plus x sub 1. Okay, so let me go ahead and plug that in. So x sub 2 I know is c plus x sub 1. All right, so I'm going to take out my x sub 2. I'm going to replace it with c plus x sub 1, and I still have my plus b over here. So everywhere that I saw x sub 2, I replaced it with what I know x sub 2 is equal to, with that c plus x sub 1. Are we okay with that? Okay. All right, next I'm going to distribute. Okay, so I'm going to distribute this m. So that's going to give me m times c plus m times x sub 1 plus b. Okay, I'm going to say then that m times c, so c is a constant, m is a constant. I'm just going to call that a constant, and I'm going to call it k. Okay, so just to give that kind of a name, I'm going to call that a constant k. Okay, what I'm trying to get to here is where I have x sub 1 plus k. Okay, because back up there in my statement, it said that f adding a constant c is what's going to give me my linear pattern. Okay, in just a minute, we'll have one that's more of an equation that you're looking for. Okay, so let me go for just a second and find f at x sub 1. Okay, if I were to find f at x sub 1, that would give me m x sub 1 plus b. Okay, see how that's what I have right here? Okay, so this is the same thing as f of x sub 1. And so I can say that all of that is a constant, which they're calling c, I'm going to call it k, a constant, plus my function at x sub 1. Okay, and I was finding that because that's what it said in my statement. Okay, in my statement it said a linear function f adding a constant. Okay, so here's my linear function f and adding a constant to it. Okay, that one's kind of weird, but we're going to do a quadratic one that's a little better here in just a second. Okay. All right, flip over on the back side and let's look at number 2. Okay, so number 2, when we talk about a sum and a constant second difference, we're talking about a quadratic. Okay, so what I want to do on number 2, and I'm going to give you a few minutes to try this one. On number 2 is I want to find 2ak squared. Okay, so if you read your statement there, it says for a function of the formula ax squared plus bx plus c, with domain values k units apart, the second difference between consecutive f of x values are constant and equal to 2ak squared. Okay, so to prove this one, we're going to use this information right here. Okay, so I'm going to use this formula that I have. I'm going to use this information right here, and I'm going to try to get it to be equal to 2 times a times k squared. Okay, so what you want to do to get started is to find f at x sub 2. Let me say that I know that, let me jump back up here, f of x, they told us up there in the top, is ax squared plus bx plus c. Okay, so I know f of x sub 1 would be a x sub 1 squared plus b x sub 1 plus c. Okay, so everywhere that I had an x, I just took it out. I replaced it with that x sub 1. Okay, so now try f at x sub 2. Okay, so plug that in and see what you can find. Okay, let me see if I can kind of help you get started here. These are hard. So I took my x sub 2 and I plugged in. So I have a x sub 2 squared. That's a squared, that's hard to see. Plus b times x sub 2 plus c. Okay, then it tells me on my paper that I know that x sub 2 is equal to x sub 1 plus k. Okay, so I took out my x sub 2's and I replaced them with x sub 1 plus k here and here. Okay, now I'm going to square this one. Okay, so if you need to, you can go over on the side and do x plus k times x plus k, or I used the shortcut and I squared the first. I multiplied the 2 together and times 2, and then I squared the second. Okay, now distribute your a and your b. So now distribute a and b. Okay, so none of that will condense. So I'm going to stop on that one for a minute. And now it talks about x sub 3. Okay, so now go and do the same thing with x sub 3. Okay, so plug in x sub 3. And then we know that x sub 3 is x sub 1 plus 2k. That was given to you on the piece of paper. Okay, so see if you can find that one. Okay, do the same thing that we did for x sub 2, but now using x sub 3. you're ready, check your x sub 3. Okay, now here's where I'm going with this. So I found x sub 1 right here. I found x sub 2 right here. I'm going to go ahead and relabel it f of x sub 2. And I found x sub 3 right here. Okay, so we talked the other day about how a quadratic is a constant second difference. So I want to subtract twice. So first I'm going to take f of x sub 3 and I'm going to subtract f of x sub 2. Okay, so that's going to be my first difference. I'm going to take the 3 and subtract the 2. Okay, so take a minute and take all of 3 here and subtract from it all of 2 here. And don't forget to distribute that negative sign when you're subtracting that one. Okay, so take 3 that you have here and subtract 2 that you have up there. I should have warned you this takes a lot of space. They didn't give you nearly enough space on here. Subtract every single term in that f of x sub 2. Subtract every single term. Okay, so when you first write it down, it should look like that with your negative sign distributed. Okay, so I wrote down all of what we had for x sub 3. And then I'm going to subtract every term in x sub 2. So minus, and minus, and minus, minus, and minus, and minus. So subtract every single term. I just ran out of room. I have to come back to the next line. Okay, so some things are going to cancel out. The a x sub 1 squareds are going to cancel out. I've got one that's positive. I've got one that's negative. Okay, the b x sub 1s are going to cancel out. One's positive, one's negative. And my c's are going to cancel out. One's positive and one's negative. Okay, so I'm going to take my 4 a x sub 1k and subtract 2 a x sub 1k's. So 4 minus 2 gives me 2. Right, then I've got 4 ak squared minus 1 ak squared gives me 3 ak squared. And then I've got 2 bk's minus 1 bk gives me plus 1 bk. Okay, now it's a second difference, right? So I'm going to go and now I'm going to subtract from that f of x sub 1. Okay, so now I'm going to do f of x sub 2 minus f of x sub 1. That'll give me another layer. Okay, so f of x sub 2. Get back up there kind of towards the top. Ax sub 1 squared plus 2ax sub 1k, ak squared plus bx sub 1 plus bk plus c. That's all of this one. Got that from there. Okay, then I'm going to subtract from that f of x sub 1. F of x sub 1 I know is a x sub 1 squared, and b x sub 1 and c, and I want to subtract all of those. Okay, so these will cancel out with my a, and these will cancel out with my b, and these will cancel out for my c. Okay, so for this one, I'm left with 2ax sub 1k plus ak squared plus bk. Okay, so I found the difference of these two. I found the difference of these two. So now in my final step, I'm going to go find my final second difference by subtracting my two results here. Okay, so I'm going to take this one, so the second difference, write that down. It's going to be 2ax sub 1k plus 3ak squared plus bk, and I'm going to subtract 2ax1k minus ak squared minus bk. I know these are intense, so I thought we'd work it together. Okay, so these will cancel out, and these will cancel out, and it leaves me with what we said at the beginning we were trying to find, 2ak squared. Okay, I was trying to find that because that's what it said on my paper right here. On my original statement, it said to make it equal to 2ak squared. So that's how I knew when to stop. And it does. Okay, that one's a lot. So let that one sink in and maybe kind of look over that one. So for homework tonight, I'd like for you just to kind of look over that one and let that one kind of sink in for you, okay? Okay, so flip over to the next page, which I think is 28 for y'all, and let's take a look at exercise number 6. And I'm going to help you with A, and then I'm going to leave B and C for you to do later in class or for homework. Okay, they've given you some information here. So what I'm going to do is I'm going to build a table. So I'm going to work A for you. Okay, I'm going to build a table. This is number 6 on here. Sorry. There we go. Functions defined by a pattern. Okay, so I'm going to make this f and f of x, or f and y if you prefer. Okay, so the left side is my domain and the right side is my range. Okay, so they've told me that x is 5 when f of x is 12, and that x is 10 when f of x is 18. Okay, so you're going to start by building your table just like that. Okay, for all 3 of these, you'll start with that same table. Okay, then it's going to tell you which type of function it wants you to use. Okay, so for example, on A, it's telling me to use an exponential. Okay, so I'm going to look back at this, and I know that an exponential is a sum product. Okay, so I'm going to have a sum on this side and a product on this side. Okay, so because they told me exponential, I'm going to use a sum on the left and a product on the right. Okay, what it's asking me to find is 20, f at 20. Okay, so I'm going to say if I'm using a sum on this side, I'm going to be adding 5 each time. So if I add 5 again, that's going to get me to 15. And if I add 5 again, that's going to give me to 20. Okay, 20 is what I'm trying to find. 20 is my goal. Okay, so what I want to find is what goes over here to go with that 20. Okay, so I know on the left I'm using a sum, but I know on the right I'm using a product. Okay, so I need to figure out what I'm multiplying by each time to get from 12 to 18. Okay, so we talked a little bit yesterday or the day before that to figure that out, I can take my 18 and divide by 12. Okay, so since I'm multiplying by something to get from 12 to 18, I can divide to figure out what I'm multiplying by, and I can reduce that down to 3/2. Okay, so I'm multiplying by 3/2. Okay, so I need to take my 18 and multiply by 3/2 to get what goes in this blank. Okay, so I'm going to go over here on the side. I'm going to say 18 times 3/2. So 2 goes into 18 9 times. 9 times 3 gives me 27. So this is going to be 27. Okay, and then I need to go one more time to get what needs to go in the orange box. So I need to multiply by 3/2 again. So 27 times 3/2. Okay, this time 2 won't go into 27. Okay, so I'm going to leave this as top times top and bottom times bottom. Let me real quick do 27 times 3. Gives me 81 divided by 2. So this will be 81 divided by 2, and that's my answer. So what's in my little orange box there is my answer. Okay, questions on that one? Okay, so I would like for you to give B and C a try for homework, or you can finish it up during the rest of the period here. So on B, you're doing a linear. So your table will start the same way. It'll start with 5 and 10 and 12 and 18. And see what you're doing with a linear. For an exponential, I was doing a sum product. And then you'll do the same thing for C and figure out what the pattern is for C. Okay, so all your patterns are written back over here. So a linear, you're going to do a sum. Okay. Any questions on the assignment? Okay, so you can have the rest of the time to finish that up. So see if you can finish B and C. All right, Hannah, that's all we're going to do today.